So our lesson for 5.4 is going to discuss how to do division of polynomials and actually simplify to a quotient answer, sometimes with a remainder, sometimes not. But before we talk about the algebra concepts, we're going to need to go back to 4th grade for a minute. So if I took the number 6,487 and I tried to divide it by 25, and we use the process of long division back in 4th grade. So you take the 25 and try to divide it into the smallest digit you can, which 6 won't work, but we can take 25 divided into 64. So the first step in long division is to divide. Well, 25 goes into 64 2 times without going over. And then our next step in long division is to multiply. So we take that 2, multiply it by 25, and get 50. And then our third step is to subtract to see what we have left over. So that would give us a 14, which is not large enough to divide by 25. So then our final step in the process is to bring down the next digit of 8. And then we start the process all over again. So remember that 4th step was to bring down the next digit. Alright, so we start all over again. This time I'm taking 148. Trying to figure out how many times 25 divides into 148. So 4 times would be 100, 5 times is 125, that's about it. Alright, 5 times. So we multiply. 5 times 125 brings us up, 5 times 25 brings us up to 125. And then we subtract. Whew, boy. Alright, so that's a 3, that's a 2, and that's not large enough to divide, so I gotta bring down the next digit and the final digit, which is a 7, so now we're up to 237. So 25 divides into 237. Well, let's see. 8 times to get up to 200, and then 1 more, so 9 times. So 9 times 25 is 225. And then on this final step when we subtract, it doesn't go in perfectly, which happens, but you end up with a 12 down here. 12. But this last digit, unless we want to start doing decimal points, this one here is going to be the remainder, this last number. Meaning it's still stuck inside of a division question. So the quotient that we could provide is 259 and 12 25ths, because this 12 is still being stuck inside of the dividing by 25 problem. Now they don't really explain this to you when you are a little kid, but 259 and 12 25ths is really a whole number 259 added to the fraction 12 25ths. That's what it really means. So we're going to keep that in mind when we do our polynomial division today. I don't know how you're going to feel about this lesson, guys, but here's the issue. It doesn't matter how you feel about long division because we have to do it anyways. Alright, so skipping on to number 1 here. We have a polynomial being divided by another polynomial. So we're going to set up our long division just like we would back in 4th grade. So x squared minus 5x plus 6 is the dividend, and we are dividing it by x minus 3, the divisor. Now I would suggest you put parentheses around the x minus 3. I think that helps. So the steps are still going to be the same. We're still going to divide first, and then we're going to multiply, and then we're going to subtract, and then we're going to keep bringing down terms until I run out of terms, essentially. So dividing. You don't have to worry about places and digits because you're just going to look at lead terms. So you're taking the lead term of x squared and dividing it by the lead term of x to the first. So x squared divided by x to the first would give you an x. So that's what I write up here on top of the division symbol. And now we multiply. So you take that number that you just came up with, x, and you multiply it by the divisor. But because it's algebra, you have to multiply it by the entire term of the divisor. So that becomes x squared minus 3x. And we write that down here. So that was the multiply step. Now we're on to subtract. So we are going to subtract normally they're digits, but in this case they're polynomial terms. So I'm going to put green parentheses around that, and I'm going to remember to subtract. Now this lead term needs to cancel. That's the whole point of this, is that it's going to be gone. So make sure that happens, and then negative 5 minus negative 3 for x's is going to come out to a negative 2x. And then just like in 4th grade long division, I need to bring down my next term. I'm using the wrong color. Look at me messing that up. There we go. And now I start the process all over again. So back to divide. You take your lead term, and you divide it by the divisor's lead term again. So negative 2x divided by x would leave us with a negative 2, and that's what I write up here. So this time, you take the negative 2 and you multiply it into the divisor. And remember, we have to distribute it. So negative 2x minus 2 minus 3, let's see, that's a plus 6. And then we're going to subtract. Lead terms should cancel, which they do, so I'm feeling good about this. 6 minus 6 is nothing. So it turns out in this question, we have no remainder, which means that these polynomials divided evenly. So you looking at all this work, you're probably thinking like, okay, great, what's my answer? Your answer is your quotient, which is the number that's at the top of the division problem. So the answer is x minus 2 is your remaining polynomial when you divide those two polynomials together. That was kind of fun, right? All right, let's try another one. X squared plus 6x plus 2 is being divided by x plus 1. So, the dividend, x squared plus 6x plus 2, underneath the division symbol. Your divisors out here, x plus 1. Like I said, parentheses. I think they really help and they encourage the distribution. All right, back to our steps. First step is to divide. So you take your lead term, divide it by the divisor's lead term as well. So x squared over x is going to give us x, because this is 2 minus 1 for the exponent rules. Now we multiply. So you take that number you just came up with and you distribute it into the divisor. I wrote that kind of weird. So that's x squared plus x. And then we subtract. The lead terms should cancel, and they do. 6x minus 1x is 5x. This is actually the step where everyone messes up right here. The subtraction of that second term, because they just forget to distribute the negative. It's very irritating. All right, and then we're going to add the 2, or bring down the add 2, and then we start all over again. So back to divide. And you know what? I didn't put all my steps in. Let me do that. So our second step was multiply. Our third step was to subtract. And our fourth step was to bring down. This just takes a little muscle memory, just like when you were a little kid and you're trying to remember how to do long division. You just have to do a gazillion problems. So the lead term of 5x is now being divided by x. And that leaves us with a 5. Positive 5. So I'm going to write down plus 5. Now I'm on a multiplication step, so take this positive 5 and distribute it into the divisor. So 5x plus 5. And this time, while the lead term does cancel like I need, there is going to be a remainder. So 2 minus 5, better known as a negative 3. This number right here is our remainder. So you might be wondering, like, okay, what does that mean for my answer? Like, what does my quotient look like? Well, up here, this is still the main part of your quotient, is x plus 5. However, remember how the remainder means it's still stuck inside of a division problem? So this negative 3 is still being divided by the divisor of x plus 1. It's stuck inside of the division. So this is my true quotient. You might see this answer written like this, though. Instead of saying plus a negative 3, they might just say a subtraction sign, and then keep the 3 looking positive because of the double negative issue there. So that would be another way to write the same quotient. Okay. Oh boy, that's a big guy. So we're going to have more terms here, which means we're going to have more levels of division. So this one's going to take more lines of work, so hang with me. All right, our dividend for x to the third minus 5x squared plus 2x minus 1. It's being divided by, again, I think you should use parentheses. I think it helps. X minus 1. All right, lead terms. 4x to the third divided by x. I think it helps me, at least, if I write the lead term division off to the side, because this is another place where kids generally mess up. This is going to remain 4x squared when I simplify that. So now I take that 4x squared and I multiply it into my divisor, and I get 4x to the third minus 4x squared. All right, subtract. Those lead terms should cancel, so I feel like I'm on the right track because I canceled. Negative 5 minus negative 4 is negative 5 plus 4, so that would give me a negative 1x to the second. And then I got to go again. I got to bring down the next term. All right, lead term, new lead term is negative x squared, and I'm dividing it by my original divisor, lead term of x. So that simplifies to a negative x, which I'm going to write right here. Now you take that negative x and you distribute it into the divisor. So that gives us negative x squared plus x. You know I love using colors in my lessons, but this is a clear-cut case for the use of colors. I think this is very hard to look at, all of this work, if you do it all in grayscale pencil. Alright, but that's my little, it's my hang-up, I guess. Alright, lead terms do cancel. 2 minus 1 will give you 1x. And we're still not done, because we have another term to bring down. So x minus 1. Now don't overthink this, guys. You're taking x minus 1 and dividing it by x minus 1. That would divide out and cancel out to a plus 1 with no remainder. But if you want to just continue on with the process, you take the lead term divided by the other lead term, and you do get a plus 1. And when you multiply the plus 1 here times the divisor, you get x minus 1. And then when you subtract that second term, you do get a remainder of 0. So your answer, your full quotient, is right here. I know I wrote all over it, but it's 4x squared minus x plus 1 with no remainder. So you don't have that weird fraction thing. Alright. So I'm going to skip this question just for the sake of time, because I have a class starting in a little bit. That's the main idea for long division. Long division for polynomials very closely resembles long division for numbers back in 4th grade. It's just a little different because you don't have the issue of like placeholders and things, and you have addition of terms that are separated. But the process is really the same. And in fact, some Algebra 2 kids claim, although I don't know if I believe them, they claim that, oh that's weird, I have some weird slides here, hold on a minute. So some Algebra 2 kids claim that after they learn polynomial long division, they not only understand long division better in general, but they actually prefer it to like 4th grade long division. I don't know why. I don't know if I agree with that, but whatever. Alright, so we're going to learn something next that's called synthetic division. And if you remember, the word synthetic used in life generally means fake. And that's exactly what it means here. So in math, you have to realize like these inverse operations, addition, subtraction, multiplication, division, they're really the same operation. They're just doing the opposites. So someone came along and they're like, what do you not like about division? And pretty much people don't like to divide, and they don't like to subtract, because that's hard for our brains to do. So then someone said, well, what if I rework the problem setup so that way instead of dividing, I always multiply, and then instead of subtracting, I always add. And they came up with synthetic division. So we're going to be able to do fake division, and this is what the setup looks like. What goes inside of this little half box here is the solution to the divisor. So that thing that we're dividing by, if I was to find his solution, that's what goes in the box. And then off to the side of the box here, we're going to line up our coefficients, and it has to be in standard form order. So the first issue with using synthetic division is, can you set it up properly? And then there's another little kicker about it being in standard form. We'll talk about that in a second. Once you get your answer, it's not going to look like an answer. So then you have to interpret what that answer really means. So I don't mind either type of division. I don't really have a preference here. Most kids decide that they like synthetic division better because they feel it's easier, but you have to do both, so I don't care. Alright, so remember, this is your divisor, and what I need you to do is find the solution to the divisor. So if you were to set it equal to 0 and solve, you would get x equals 3. So you're going to put the solution to the divisor in the half box, and then you're going to look at your polynomial that you're trying to divide into, the dividend, and it's in standard form. You also have to make sure that there's nobody missing. Like if it skips from a cubic term to a linear term and it skips over the quadratic term, we're going to have to put a 0 placeholder there to keep everything lined up. So in this case, it doesn't skip anything. It goes cubic, quadratic, linear, constant. Alright. So now I'm going to just write down the coefficients. So this guy has a coefficient of 1, a coefficient of -2. Next coefficient is -10. Oops, wrong color. And then our final coefficient for the constant is -15. So when we do synthetic division, you have to have it set up properly, and then you need a place to get going. So you take the first coefficient and you're going to bring it down below the line to where your answers are going to be in a moment. So this is the first lead-off coefficient. From here, it's just a series of multiplications and then additions. So it's a two-step process once you get it set up. Alright, so to multiply, you take this 1, this lead-off coefficient, and you multiply it by the solution of the divisor. So 1 times 3 is 3, and you write it in the next open spot, which would be right here. And then we add up the column. So -2 plus 3 is 1. And now we start all over again. So now I take this 1 and I multiply it by 3. I get a 3, and I write it in the next available spot. And then I add up that column. -10 plus 3 is -7. And one more time, take the -7 times the 3, and I get a -21. And then I add up that column. I feel like I messed up somewhere. 1, -2, -10, -15, 1, 3, 2, 1, 3, -7, 21. I don't know. I don't think I messed up anymore, but I don't remember that answer. That's the only reason I was wondering. -37. All right, anywho, when you do synthetic division, the last number you get here, this is the remainder. So now the trouble is, these are the coefficients of your quotient. You've got to figure out how to write that down in a polynomial. So think about what we were doing, guys. We were taking an x to the third power and dividing it by an x. So if you took an x to the third power and divided it by an x to the first power, that would leave you with an x squared as your leading term to your answer. So this guy is 1x squared, and then it goes down the line from there. So 1x squared plus 1x minus 7 as a constant. And then remember, our remainder is still stuck in the division, so this -37 is still being divided by the x plus 3. But also remember, when we had this weird plus negative thing, sometimes we wrote the answer as x squared plus x minus 7, and then we just say subtract 37 over x plus 3. Alright. Again, I feel like I made a weird dorky mistake there, but I guess time will tell, huh? I'll have to re-record this whole lesson if I made a mistake. Alright, so this guy, same process, same setup. We take the divisor and you find his solution. So his solution would be x equals, oops, -6. You can't read that though. X equals -6. So that's what I put in the little half box. Sometimes kids say, do I just take the opposite? It's not as simple as just taking the opposite sometimes. So just think of it as the solution to the divisor. Then I set up my coefficients. It goes quadratic, linear, constant, so there's nobody missing. 1, -1, -42. And we get the process going by bringing down this first term. Alright, now it's just a series of multiply, add. So I multiply 1 times -6 and get -6. And then I add up that column and I get -7. Now I take that -7 times the -6 and I get positive 42. And then I add up that column and I get nothing. So remember, this last number you get is the remainder. So I don't have to do that weird plus fraction thing. And if I think about my original problem, a quadratic divided by a linear would leave you with x as the lead-off term here. So this is 1x and then -7. You don't have to do the weird fraction thing because there's no remainder. Now there's a little note here. If the remainder equals 0, then that means that the divisor is a factor of the dividend. So yeah, the factors of x squared minus x minus 42, aren't they x plus 6 times x minus 7? So that's why we ended up with no remainder, because the x plus 6 was a factor of this, so it divides in evenly, and that's what it means to be a factor. Alright, oh, this one's a little bit tricky, because the solution to the factor is nothing weird. That's just going to be a -2 when I solve that. But look at the coefficients here. I have a cubic, and then it skips all the way down to a constant. So what you have here is x to the third power plus no quadratic term plus no linear term, and then you have a constant term. So when I line up my coefficients now, I have to say 1, and then a 0, and a 0, and a -8. Alright. Bring down your lead-off term, and then we do a series of multiplies and adds. So multiply, I get -2, and then add up that column, and I get -2. Alright, multiply the next one, I get +4, add up that column, and I get 4. Not very exciting math. One more. Multiply 4 times -2, and I get -8. Now, these do not cancel, so be careful. -8 plus -8 is actually a -16. So this time I do have a remainder. I just have to figure out how to write my answer. So I started with an x to the third power, and I divided it by an x to the first power. So that would leave me with an x to the second power as my quotient. So this is 1x to the second power minus 2x plus 4 as a constant. And then since we do have a remainder, I have to write that weird fraction thing. Instead of saying plus negative, I'm just going to write subtract 16 over, still being divided by this x plus 2. That is so not legible, so try again. X plus 2. Alright. There's our quotient with remainder fraction. Perfect. Let's see what the next example is. That's a good one to do. Solution to your divisor is a -2. Lining up my coefficients, do you notice that it skips a coefficient right there? There's no linear term. So I have 2, 6, and then we're missing the x term, and then -9. Now, little side note, if there's no constant, that is also a missing term. So like if your problem stopped at the quadratic, you had to put 2 placeholders in that case to go all the way down to the constant. So keep that in mind. I think that does show up in your homework. So bringing down our lead-off term of 2, let's start multiplying and adding. So multiply, you get -4. Add it up, you get 2. And go all over again, multiply, you get -4 again. And then add them up and you get -4. One more time, multiply, you get +8. And then if I add up that column, I get -1. So this time I do have a remainder again. So we're going to have a weird little fraction thing. I don't know why all of our remainders keep coming out negative on this worksheet, but oh well, you'll get over it. We just have to figure out how to kind of translate these coefficients. I had a 2x to the third power divided by x. So if you think about what my lead term should be a 2x squared. So that's what it's going to be as long as I fill in an x squared. So 2x squared plus 2x minus 4. And then instead of plus -1, I'm just going to say minus 1 over x plus 2. There's our great answer right there. All right. I think we'll call it a day there. I'm sure there's some other questions that are going to show up in your notes and your lessons, but we'll just call those extra practice for our class. Long division and synthetic division, you have to know how to do both. They're going to be 2 separate skills for you, okay? So I realize you might have a favorite at this point, but we're going to practice them both. Good luck.